Hi students, good evening to you. Welcome to this video session. I remain Samuel Chukwuemeka, aka Sam Dom for Peace. As usual. In this video session we shall discuss ratio, proportion, similarity and congruency. This will be part one of the video because we will have several parts to it. We shall focus mainly on ACT problems since I am preparing you for ACT. So any topic I teach you in geometry, we shall look at the questions on that topic on the ACT and solve it. Because one thing with mathematics is you need to know the several ways they can ask the questions, they can twist questions. So it is important that you view all the videos I do in geometry. Very important. You can go to my website, samuelchukwuemeka.com, or you can go to this website, chukwuemeka-samuel.appspot.com. This one is more, this website is responsive layout, so this should be more mobile friendly, and tablets are mobile friendly. You can use this website. It's going to be the same content whether you go to samuelchukwuemeka.com or whether you go to chukwuemeka-samuel.appspot.com. It's gonna be the same content, but this is gonna be more mobile and tablet friendly. Okay, so we are going to start with vocabulary words. You need to know the vocabulary, and then we shall solve some of these questions. I will tell you the A for the question, and you can check it out yourself. We shall solve some years based on what we cover tonight. And if you see anyone that is still under this topic, you know, that for the years I will call out tonight, if you see any question under this topic that I did not solve, just let me know. Okay, let me know. But any topic I teach you in geometry, we are going to solve all questions based on that topic from the ACT, because I really want you to do well on your ACT, and you have several geometry questions that come out on the ACT. Okay, so let's look at the vocabulary words, and we shall define this. We have what we call the ratio. We have extended ratio. Then we have proportion. We have extremes. We have means. We have cross products. We have extended proportion. We have scale factor. We have similar figure, we have similar polygon, we have similar triangles, we have congruent figure, we have congruent figure, we have two-dimensional shape, or plane shape, two-dimensional shape, okay, two-dimensional shape, we have we have an axiom, postulate, okay, and we shall excuse me, as we move on, we shall have more terms as we move on. But let us start with these terms first. Let us begin with these terms, and as we move on, just add. As we move on, just add to what we have. This is 2D. Okay. So, what do we mean by a ratio? What do we mean by a ratio? So we say that, and I will dictate, and you can write down. Okay. We say that a ratio is a comparison of two quantities by division. Okay. Comparison of two quantities. You're comparing two quantities by division. Or you can say a ratio is the quotient of two quantities. Quotient is the answer you get after division. Okay, quotient is the answer you get after division. So you can define a ratio as either, you can say a ratio is the comparison of two quantities. You're comparing two quantities by division. Or you can say a ratio is the quotient of two quantities. So we express this division, okay? So we express, let's say, ratio of 2 to 3, for instance. We have three ways of writing ratio. Three ways of writing ratios. The first way, you can say ratio of 2 to 3. Ratio of x to y. Something, okay? Ratio of 2 to 3, ratio of x to y. Ratio of x to y. We say ratio of x to y. Let's write this. Ratio of x to y. Ratio of boys to girls. Another way you can write this is 2 over 3, like a fraction. You can write x over y just as a fraction. Okay? You can write the ratio as a fraction. Or you can write it 2 to 3, x to y. Okay? This is a fractional notation. Writing it as a fractional notation. Another way you can write it is by saying 2 is to 3. 2 colon 3. X colon y. Okay? X colon y. The colon notation. So you have the regular notation like 2 to 3, you can say in words, okay, 2 to 3. Then you have it as a fraction, fractional notation, and you have it in colon notation, 2 colon 3, x colon y. So that is the way we write. These are the 3 ways we write ratios. And you see here it compares 2 quantities. Okay? So let's say maybe I have in my class, say I have uh, 30 students in my class. Okay, in my class. Let's say I have 16 boys and 14 girls. Okay, 16 boys and 14 girls. Right? So what is the ratio? What is the ratio of boys to girls? What is the ratio of boys to girls? You look at this now. I have 30 students in my class, 16 boys and 14 girls. What is the ratio of boys to girls? Okay, and don't mind the barking in the background. I fed my dog today. I don't know why she's barking. I don't know. But I don't want her to mess up, to bring her into the house and mess, and she will not allow me to teach. So don't mind the barking, okay, in the background. So she wants to come into the house, but no, I'm teaching. So you have 16 boys and 14 girls. What is the ratio of boys to girls? Okay? What is the ratio of boys to girls? You will now see, because these are 2 quantities here. First quantity is boys, second quantity girls. What's the ratio? So ratio of boys to girls would be ratio of boys to girls would be 16 over 14. Okay? So, or you can write 16 is to 14. Now, we always want to simplify ratios. We always want to simplify ratios. Okay, you always want to simplify it. Or you can just say, simplifying it, 16 divided by 2 is 8, 14 divided by 2 is 7. 8 is to 7. Okay, so this is the ratio of boys to girls. That is what it is. Does that make sense? Okay. Then the next one was extended ratios. Extended ratios. What is extended ratio? Extended ratio is a ratio of 3 or more quantities. Ratio of 3 or more quantities. Okay, is what we know as extended ratio. Okay. By the way, what if I ask you ratio of girls to boys? If I ask you ratio of girls to boys, that would be 14 over 16, okay, which is also equal to 7 or out of 8, 7 over 8. Or you can say 7 is to 8, 7 colon 8, or you just say 7 to 8. You can write ratios any of these ways. Now, then the second one was extended ratio. What is an extended ratio? An extended ratio is a ratio of 3 or more quantities. So let's say we have maybe Let's say we have maybe Mr. C bought 50 fruits. Okay, 50 fruits. I like oranges a lot. I like oranges a lot. So let me say 30 oranges. 30 oranges. 15, what other food did I like? I like oranges, I like pear, but the pear I like is not the avocado. Well, I like avocado pear, but the normal pear we have, ubibo. Ubibo, that's from Nigeria, Nigerian pear. But let me say what probably the fruits I like here. Let me say 30 oranges, 15 pears, let me just put pears, and then 5 blackberries, or blueberry, 5 strawberries. Okay, so if I want to find ratio of pears is to strawberries is to oranges. Okay, now you see these are 3 quantities. So ratio of, say, pears to oranges to strawberries. So that would be what? 15 is to 30 is to 5. Okay? So that is the way we can express it. This is extended ratio, comparing 3 or more quantities. Okay, now let's look at the next one, proportion. So proportion is defined as an equation, okay? Proportion is an equation stating the equality of ratios. Proportion states the equality of ratios. It's a mathematical statement that 2 ratios are equal. Equality of ratios. So proportion is a mathematical statement that states the equality of ratios, or that states that 2 ratios are equal. You can put it that way. Or proportion is the equality of 2 ratios. You can just say a proportion is the equality of 2 ratios. So it's 2 ratios now, 2 ratios, okay? So if we have something like, maybe we have a 16 over 14 equal to 8 over 7. So these are 2 ratios, okay? So this is the first ratio and this is the second ratio. That is what we mean by proportion. Equality, because of the equal sign. So equality of 2 ratios is what we mean by proportion. If you look at this proportion, for instance, I'm going to use colored chalk here. You look at this proportion, you'll see this is like stating that 16 is to 14 equal to 8 is to 7. So you look at this proportion here, when we do cross products, you see these 2 here, I did with yellow. The numerator on the left hand side multiplying the denominator on the right hand side. And I'll use another colored chalk here. And the denominator on the left hand side multiplying the numerator on the right hand side. So this must happen in only two. Okay, this is what we call cross product. You see, it looks like a cross. Now, but let's look at this first. If you look at this for a moment, this 16 and this 7, this 16 and this 7 is what we call the extremes. Extremes. We call them the extremes. The 16 and 7 are called the extremes. 16 and 7. Extremes are 16 and 7. We call them the extremes. And then this one here, this middle one's 14 and 8. Okay, the denominator on the left hand side and the numerator on the right hand side are what we call them the means. The means. So the means are 14 and 8. Okay, the extremes and the means. Now, so you see that these are the extremes and these are the means, the middle here, 14 and 8. So when we talk of cross product, yeah, when you write, so if we give the definition, when you write a proportion in such a way that the ratios are written in colon notation, you see this ratio is in colon notation, this ratio is in colon notation. The ends are the extremes, and the middle two numbers are the means. When you write the proportion in such a way that the ratios are in fraction notation, then the numerator on the left hand side and the denominator on the right hand side are the extremes, while the means are the denominator on the left hand side and the numerator on the right hand side are the means. Does that make sense? Okay, this is known as the numerator, the top, and this is known as the denominator of the fraction. The same thing with this. So those are what we mean by extremes and means. Now, what is cross product? Cross product is the product of the extremes and the product of the means. Okay? Cross product is the product of the extremes and the product of the means. In a true proportion, the product of the extremes should be equal to the product of the means in a true proportion. So anytime we solve proportion using cross products, we equate the product of the extremes to the product of the means. Okay? So that is what we mean by cross product. Alright, let's look at an example and then let's do an example and then we continue. So here I have ACT 1996 from 1ST. So this is a 1996 from 1ST. So I have a 9 over 6 equal to P over A. So they say you should find P. Yeah. By the way, the ACT are multiple choice questions. For the most part, I will teach you that without having to write all the multiple choice options. Okay, so that we can, we have a lot of questions to solve. So this is a proportion here. This is a proportion, and we say that in a true proportion, you equate the means to the cross product. So We are going to solve this proportion, and we are going to also look at, we have to now discuss how many ways you can solve proportions. And keep in mind that you're working on the ACT. So one question is 1 minute. You have 60 questions for 60 minutes. So one question is approximately 1 minute. However, some questions in the ACT, they set it in the ACT, they set the questions such that some questions will take you less than a minute to solve. Some questions will take you less than a minute. So, and some questions will take you more than a minute. So one of the things they are measuring is not just whether you know the question, but how accurate, how fast and accurate you can be to solve those questions. So you want to use the easiest method to solve it. You really want to use the easiest method. Anytime you can use the easiest method is the best to solve it. Okay? Let me write this here. Let me write this here again because I will need this. So Mr. C has 30 students in his class, 16 boys and 14 girls. Okay, so now let's look at solving proportions. Solving proportions. Solving proportions. So one is by cross product. Cross product. Okay? Now you make sure it must be two ratios. Must. It must be a proportion. Must. Two ratios only. Okay? And the other one you can have by multiplying both sides by the LCD. By the LCD. LCD is least common denominator. If you don't know how to find the LCD, okay, you can view the videos I did on factors and multiples. Factors and multiples. It's under algebra. It's under algebra. The video I did on factors and multiples. So it is my expectation that you know the basics of, you've done algebra before you do geometry. It is my expectation. So with the cross product, okay, we say from here, if we're doing cross product, we have it that 9 times 8 is P times 6. And we can divide both sides by 6, okay? P is 9 times 8 divided by 6. So 3 into 6 is 2, 3 into 9 is 3, 2 into 2 is 1, 2 into 8 is 4. I have that P is 3 times 4, which is 12. Okay. This could take you less than a minute to do by cross product. Could take you less than a minute. And you can use your calculator. In ACT, they allow you calculator. So if you feel that you are not good with multiplying, just use your calculator, okay? 9 times 8, 72, divided by 6, 12. So that you continue. So, but there are some questions, trust me, there are some questions that using a calculator will even slow you down. Or using a calculator, you might not even see the answer in the option. So when we come to those questions, I will let you know as well. But in this case, you can use a calculator to speed you up. Now, this is just one of it. What if you want to do it by LCD? Another way you can do it by LCD, okay? You can have it this way. If you use LCD, you see that LCD of 6 and 8 is 24. Okay, it will give us 24. If you don't know how I got 24, then you go and view the videos I did on this under algebra, factors and multiples. Okay? So you just multiply both sides by the LCD. So this will be 24 times 9 over 6 equal to 24 times P over 8. So 6 into 6 is 1, 6 into 24 is 4, 4 times 9 is equal to 8 into 8 is 1, 8 into 24 is 3. 3 times P, 3P. So you now have that P is 4 times 9 over 3. So 3 into 3, 1, 3 into 9, 3. So P is 4 times 3, which is 12. P is 12. Yeah. So this is using the second way, multiplying both sides by the LCD. With this way, it is longer. So for this kind of question, I suggest you just do cross product. And you can use, if you are not good with multiplication tables, you can either memorize, you can either go back and learn it, or you use your calculator, since they allow calculators. Okay? There are some, however, there are some ones we shall do that will need you to use LCD. When we come to those ones, we shall look at them. Okay? But these are the, for the most part, the two basic ways you can solve proportions. Okay, now let us look at this for a moment. Let's get back to this here, this question here. So, what if, the question Mr. C has 30 students, 16 boys, 14 girls. What is the ratio of boys to girls? 8:7. Good. Okay, what if we go backwards? Okay, what if we go backwards? What if I give you the ratio, give you how many students I have, and then I now ask you the number of girls or number of boys? Like doing it backwards. Because you need to know how to do it backwards. So, let's say I have the ratio of girls to boys in Mr. C's class. In Mr. C's class is 7:8. 7:8. Okay? If he has 30 students, if there are 30 students in his class, some people will say if he has. Okay, if there are 30 students, in his class, how many girls are in his class? How many girls are in his class? Okay? So, in this case, this is like working it backwards. Okay, so if you're given the ratio and you're not asked to find the number, in this case, the first thing you do is you first of all do sum of ratios. And the sum of ratios is 7 plus 8, which is 15. Okay, that's the first thing you do. Then you now say, okay, that the number of girls, because this is girls 2 boys, So you now say that the number of girls would be, because the ratio is 7, okay, it's here. So 7 over 15 times the total number 30. Okay? That's the ratio. So you first of all find sum of ratios and you do 7 over 15 times 30 over 1. So 15 into 15 is 1, 15 into 30 is 2, 7 times 2, and that will give you 14 girls. 14 girls. Okay? And if you want to find the number of boys, you can just do 30 minus 14, which is 16 boys. Or you can do 8 over 15 times 30 over 1. And that gives you 8 times 2, which is 16 boys. Okay? Now, let me say this. They must not give you 7:8. They must not. They could give you 14:16. They must not give you 7:8. They could give you 7:8. They could give you 14:16. And if they give you 14:16, okay, you still have to do sum of ratios. 14 plus 16 is 30, and you do 14 over 30 times 30 over 1. That gives you 14 girls. They could also say it's 21:24. Okay? 21:24. They could also say what? 28 is to what? 32. Similar ratios. Okay, similar ratios. They could say this. They could also say 35:40. You know how I got it, right? By multiplying by 2 by 2. This is by 3 by 3, by 4 by 4, and so on. They can say 35:40. But whatever they say, just make sure you do sum of ratios, and then you can now use it and solve it. It will still give you the same answer. Alright, the same thing here. Coming to extended ratios. They can say that the ratio, of pears to oranges to strawberries. They can say this question, ratio of pears to oranges to strawberries is 3:6:1. Okay? 3:6:1. They can say this. And they say you have 50 fruits. How many strawberries? How many strawberries? Okay, how many strawberries? Do you understand what I'm saying? So in this case, if they ask how many strawberries, you do 3 plus 6 is 9, plus 1, 10. 1 over 10 times 50. 1 over 10 times 50. And that is 5 strawberries. The same way, if they give you the ratios, whether it is ratio or extended ratio, and they want you to find number of something, just first of all add up the ratios and then use the specific ratio divided by the total number of ratios by multiplying by the total number of quantities you're given. Okay, that is how you do it. So that being said, let us do another question on the ACT. And that one is I'm still on ACT 1996 Form 1 ST. Okay, I'm still on ACT 1996 Form 1 ST. So it says here the length of the sides of a triangle are 3, 8, and 9 inches. And 9 inches. Okay, then it now says how many inches long is the shortest side of a similar triangle. We're going to define this in a moment. Similar triangle that has a perimeter of 60 inches. Okay? So look at this question here. The lengths of the sides of a triangle are 3, 8, and 9 inches. How many inches long is the shortest side of a similar triangle that has a perimeter of 60 inches? So this is the same, this is similar to what we just did here. Similar to it, okay? So we have two triangles, a triangle and a similar triangle, and these are the lengths of one. So the perimeter is like the total distance of a triangle, the total distance. So this is similar to saying that the sides of the triangle are in the ratio. Size of the triangle, this is the question here. This is like saying that the sides of the triangle are in the ratio of 3:8:9. This is an extended ratio. Okay? This is an extended ratio. So how do we solve this? Now, let me say this. I would like you to, if I write any question, because I will explain a concept, and then I will look at the questions on that concept, and we solve it. When I write the questions, I would like you to first of all pause the video, pause it, solve it on your own, and once you solve it on your own, then you play it and see whether we get the same thing. Okay? So here the sum of ratios here is 3 plus 8 plus 9. And then 3 plus 8 is 11 plus 9, 20. So now the shortest side, of course, is going to be 3. The one that has, 3. That's the shortest. So the shortest side, length of the shortest side, you can say length of side, or you can just say side. Okay? Let me write, length of side means just side. You can say length of side, or we can just say side or side. Okay? So when we talk of that, just know we mean the same thing. So the length of the shortest side, is 3/20 times the perimeter, the total distance from 60/1. So 2 into 2, 1, 2 into 6, 3, 3 times 3, 9 inches. 9 inches. That becomes the answer. Okay? Alright. Back to the vocabulary. As we move on, we will solve problems here. Okay? Now, back to the vocabulary. The next one is extended proportion. What is extended proportion? Extended proportion is just is the proportion of 3 or more ratios. Equality, because proportion is equality of 2 ratios. Okay, proportion is equality of 2 ratios. But if we want the equality of 3 or more ratios, we call that extended proportion. Okay, extended proportion is the equality of 3 or more ratios. Okay, we will do, when we come to a question like that, we'll come to that in a moment. We will come to a question that uses it. Of course, this question also uses it, but we shall demonstrate it with the triangles, okay, in a moment. The next one was what? After extended proportion, what was it again? Similar figures. Now, what are similar figures? Similar figures are figures that have the same shape. They have the same shape, but not necessarily the same size. Okay? You have similar figures, compare and contrast, similar figures, congruent figures. With similar figures, number one is same shape. Okay, figures that have the same shape, congruent figures, same shape. Then, not necessarily the same size. Not necessarily the same size. Not necessarily the same size. But this has same size. Okay? Similarity. Okay, we say the symbol for similar is like this. Okay? Like that. What do you call this? Something like a negation. Okay? But we call it similar, like this. And then the congruency, the symbol is like this. Congruency is like this. This equal to congruency. Usually we say, we usually use sides, similar. Whenever we talk of sides, then congruency we use angles. We don't say similar angles. We say congruent angles. Similar sides. Does it make sense? You can add it number 4. You can add it as number 4. We usually use it for sides, similarity, and then congruency we use it for angles. Okay, we don't really say congruent sides. We say similar sides, length of similar sides. Okay, and then congruency, congruent angles. Angles are congruent or just equal. Angles that are congruent. So that is the compare and contrast. And then similarity. Similarity is the state of having similar figures, or the phenomena of having similar figures. The state of having similar figures is similarity. And then congruency. We don't say congruentity. So congruency is the state of having congruent figures. Okay. Similarity is the state of having similar figures. Congruency is the state of having congruent figures. Now let us look at similar polygons is the next one, right? So what is a polygon first? What is a polygon? A polygon is a 2D, it's a two-dimensional. So of course similar polygons, you will say polygons that have the same shape but not necessarily the same size. Those are similar polygons. But then what is a polygon? A polygon is a two-dimensional figure with straight sides. Okay? A polygon has straight sides. It's a 2D, a two-dimensional figure with straight sides. A circle is not a polygon because circle has curved sides. Okay. Now what is so examples of polygons, we have triangles, 3 sides, 4 sides are quadrilaterals. Quad. Okay, and quadrilaterals, we have squares, we have rectangle, square, rectangle, rhombus, kite, parallelogram, trapezoid. Trapezoid and trapezium are the same thing. Trapezoid and trapezium are the same thing. Americans will call it trapezoid. Nigerians will call it trapezium. Nigeria and Britain, okay? Nigeria and Britain will call it a trapezium. America will call trapezoid. It's the same thing. Okay. So quadrilaterals, you have square, rectangle, rhombus, kite, parallelogram, trapezoid, or trapezium. Then if it is 5 sides, it's a pentagon, pentagon. 6 is hexagon. 7 heptagon. 8 octa, okay, octagon. 9 nona. 10 decagon, decade, decagon. 11 hendecagon. 12 dodecagon. Okay, so these are polygons. Now, what are two-dimensional figures? Two-dimensional figures are plane shapes. Okay, they are plane shapes. They have 2 dimensions, such as height and width. Okay, they have just 2 dimensions, such as height and width and length. Okay, only 2 dimensions. All right. Now, let us look at similar figures extensively and solve questions about it. Okay? Solve questions with it. So let's say in a similar figure, for 2 similar figures, okay, or you can say polygons. Number 1, congruent, the corresponding angles are congruent. Corresponding angles. This is what I mean by angles. So please, this is what I mean by angles. Corresponding angles are congruent. That's number 1. Number 2, the lengths of the corresponding sides are congruent, are similar. See, when you talk of angles, you talk about congruent. When you talk of lengths of sides, you talk of similar. The lengths of the corresponding sides are proportional. Okay, the lengths of the corresponding sides are proportional, or you can say corresponding sides are proportional. Okay, lengths of the corresponding sides, or you can just say corresponding sides. Okay, when we say length of side, we just mean side. You can also say corresponding sides are proportional. So these are 2 things you need to note for any similar figure. 2 things you need to note. 2 things you need to note. That the angles are corresponding angles are congruent, and the lengths of the corresponding sides are proportional. Two things. And that reminds me, the next vocabulary word, scale factor. Scale factor means the ratio of the corresponding size. Or you can say ratio of the corresponding size of two similar figures. Okay, scale factor is a ratio of the corresponding size of two similar figures. That is what we mean by scale factor. Okay, ratio of corresponding sides of two similar figures. Or you can say ratio of the lengths of the corresponding sides of two similar figures. We call that scale factor. So all these vocabulary words, you need to, take note of it. Okay, let's see a question here. Let's look at this here. If the triangles in the figure are similar, this one is a ACT 1996 Form 52C. ACT 1996 Form 52C. Form 52C. So it says if the triangles, let's call this question 3, if the triangles in the figure are similar, then alpha is what? Then alpha is, so look at the triangles here. They do something like this. Something like this. Okay, something like this. And they had this as 84 degrees. They had this as the alpha. They had this as 46. So you look at this here, they want you to just find alpha. That's all. So if you look at this, they say the triangles are similar. Okay? They say the triangles are similar. So this is just, then this, because it are similar, this here is going to be 46 degrees. It will be 46 degrees because the corresponding angles are congruent. Okay? Let's say I'm going to write the reasons for you. I'll write the reasons for you. So let me call this A, B, C, D, E. Okay? A, B, C, D, E. I will throw all my work because I'm not in the exam mode. Okay, I'm teaching this topic. So I'm not in exam mode. If I was in exam mode, I know the answer right away. This will take me less than a minute, of course. Less than a minute, about 30 seconds. Okay? So, but I will show all my work because when I ask you this question on the test, I expect you to give me the reason for each. Okay? But in the exam mode, you should know the answer. This is 46, add it to 84, and subtract by 180. You subtract from 180 to get alpha. So, but on the test, I would like you to make sure you give me the reason for each of them. Because in as much as I'm preparing you for ACT, I'm also concerned about my own test in class. So, and you've got to show all your work. And one thing with geometry, for all the tests you will have in geometry, anything you write reason. Anything you write reason. So they told us that these triangles are similar, like that. They didn't give us the, triangle, this is similar to this. They just gave us this. that these are similar. So in that case, we see that angle A is equal to 46 degrees. Reason corresponding angles of similar triangles, okay, are congruent. Okay. Then you now say that alpha is 180 minus 46 plus 84. Reason, sum of angles of a triangle. Okay, so this is now 180 minus this is 150. 130, I mean 130, right? So alpha is what? 50 degrees. That's it. Okay? Does that make sense? So I want you to show all your work. Right? Just writing alpha 50 degrees is not enough for me, no. You've got to show me all your work. So that is how I want you to do it. Okay? Now let's do another one. Let's look at another one. And then we will look at the postulates. After we do this one, then we can do let's go ahead and do postulates, and then anyone we do, let's just mark it off. Anyone we do, we mark it off. Proportion. Yeah, all this will be proportion. This will be proportion. Okay. Okay, look at another one here. Although this one is not similar triangle. This one is extended ratio. So I think we've done how many questions so far? 1, 2. We just did this one, 3. 1, 2, 3. Okay. So this will be number 4. Question 4. This is an extended ratio, and after this we can look at we will look at postulates. We look at postulates. And then axioms for similar polygons and also similar triangles. And then we can look at the proportions. We solve more problems on proportions. Okay, number 4. This is a 1997 Form 2 ST. This question here is 1997 Form 2 ST. So what I'm doing now is 1996 and 1997. Okay, those are the 2 years I'm doing for this video. Okay, 1996 and 1997. 1997 Form 2 ST. It says the ratio of the lengths of the sides of a right triangle is 1 is to radical 3 is to 2. 1 is to root 3 is to 2. What is the sign of the triangle's smallest angle? What is the sign of the triangle's smallest angle? What is the sine of the triangle's smallest angle? This is still on ratio. This is an extended ratio. So you have done right triangles. You have done it. Okay. So in right triangle, and you can, if you don't know, you can take this down. In a right triangle, of course, we have the Pythagorean theorem. Okay. In a right triangle, of course, we have the Pythagorean theorem that the height squared is equal to length squared plus length squared. This is Pythagorean theorem. If you have forgotten it, then you can view my videos. You can view my videos on the Pythagorean theorem. Okay? If you have forgotten it. Then number two, we say that of course the hypotenuse is the longest side. Okay? And it is opposite the longest angle, or it faces the longest, the largest angle. Okay? You can write number two, the hypotenuse is the longest side, and it is opposite, or you can say it faces the largest angle. Similarly, the shortest side faces the smallest angle. Okay? Similarly, the shortest side is opposite. When I mean opposite, it faces, okay? It faces the smallest angle. So, we got some work here, a little bit of work. First of all, we need to find which of these is they say what is the sine of the smallest angle, sine. And of course, you have the SOHCAHTOA one, okay? You have the SOHCAHTOA one. So, we need to find which of these is the hypotenuse, okay? Which of this is the hypotenuse? Then we put the 90 degrees there, okay, because the 90 degree is the largest angle. The hypotenuse is the longest side. It fetches the largest angle, which is 90 degrees. Okay? That's the largest angle in a right triangle. It's 90 degrees. So the hypotenuse faces it. It is opposite it. Okay? And it is the square of the hypotenuse is the sum of the squares of the two other sides. So in this case here, if you look at this, you will see that 2 squared is equal to 1 squared plus root 3 squared. If you look at this, okay, you see that 2 squared is 1 squared plus root 3 all squared. So this is 1 plus 3. Okay? 4. So 2 is the hypotenuse. 2 is the hypotenuse. It's 2. Okay? So now, let us go ahead and draw the right triangle. This is 2. 2 will be here. Then you look at, we can say, we can call this alpha and beta. Okay? So, if we want beta, if we want alpha to be the smallest, let alpha be the smallest angle. Okay, let alpha be the smallest angle. So in that case, the side that will face it is the shortest side. So you ask yourself, between 1 and root 3, which one is shorter? Root 3 is 1 point something. Root 3 is 1 point something. Okay, it's bigger than 1. So 1 is the shortest. So the 1 is gonna be here. The 1 will be here. Okay, the 1 is gonna be here. So because it's gonna face the smallest angle. So in this case, you now have that sine alpha is opposite over hypotenuse. Opposite this, because this is the adjacent here. This is now gonna be root 3. Okay, so sine alpha is opposite 1 over hypotenuse 2. So this becomes the answer. The answer is 1 over 2. Okay, the answer becomes 1 over 2. The sine of the smallest angle. All right, let us look at let's look at uses of proportions. Then we solve some problems on it, and then after that we can look at the postulates. Okay, we look at postulate. Let's look at the uses of proportion. Uses of proportions. Why do we learn proportions? And you have a lot of questions. You know, they ask a lot. For the 2 years already, they asked several questions. Actually, this is 3 years, because 1996 is 2. 1996 from 52C, 1996 from 1ST, and then 1997 from 2ST. So I'm doing 3 years. 3 years actually here. Why are we learning proportions? First and foremost, is used for proportional reasoning. For proportional reasoning. Proportional reasoning. This is very, very important here. Very important. You know, for both proportion and extended proportion. It's very, very important. Proportional reasoning. We can use it to find the measurements. Measurements. Okay, measurements. It's based on one of the methods is proportional reasoning. The second one is used to solve problems involving similarity and congruency. Okay, used for solving problems involving similarity and congruency. Okay, so we have several questions. Number, let's start with a simple one. This one is 1996 from 52C. 1996 from 52C. And this will be question 5, is that right? Question 5. 1, 2, 3, 4. Yeah, this will be question 5. Okay, it says if you have traveled X miles per hour for 3 hours, how many miles have you traveled? If you have traveled X miles per hour, per hour, per hour, per hour, X miles per hour for 3 hours. many hours? How many miles have you traveled? So some of you are very good mental math. Some of you are very good mental math. This takes you less than 10 seconds. X miles per hour for 3 hours is, how many miles have you traveled? 3x. 3x. So it's just less than 10 seconds. You answer it. So that those questions that take you more than a minute, you know, it is said, the ACT is set in such a way that you have questions that take you less than a minute. You have questions that will take you more than a minute. Those ones that take you more than a minute, don't struggle with it. Just first of all, look at all the questions first. When you're giving ACT, you know, you pray to God, then you start. You look at all the questions first. Take about a minute or 2 minutes. Look at the whole 60 questions. As you go through each question, check the ones that will take you more than a minute to solve. And you know those ones, okay? You must not begin from question 1. You must not. Okay, check the ones that will take you more than a minute to solve. Once you finish checking it, then begin with the simple ones you can knock off immediately. Ones like this. Okay, so that when you finish with these simple ones, then you now come back again, looking at your time, you check off the ones that will take you more, you know, out of those ones you checked, check the ones that will take you more time again. Okay, you can double check. Yeah, you make 2 checks for the ones that will take you more time again. And you start with the single checks. Knock it off, then you spend your time on that. But make sure you answer all questions. Okay, make sure you don't leave any question blank. No. If it is about a minute to go, 1 minute to go, just pray to God and begin to check the ones, check all unanswered ones, you know. Put something in there. Don't leave it blank. Do not leave it blank. Okay? Alright, so how would you do this question? We first here for proportional reasoning, you ask yourself, what are the 2 variables? What are the 2 variables? With proportional reasoning, for proportional reasoning, you ask yourself, what are the 2 variables they are talking about in this question? There are 2 variables they are talking about. Miles and hour. Miles and hour. Hour. So it says X miles per hour. Per hour means 1 hour. 1 per hour. 1 hour. And then it's X miles. So how many miles for 3 hours? Where would you put 3? Under hours. 3 will now be what? This is what they're asking. What would you put there? And what you could do is cross product. Okay? What you could just do is cross product. If we want, we can put this as y. Okay? What we're looking for, we can put it as y. So we could just say x over y equal to 1 over 3. And then you do what? Cross product. Cross product. Cross product. So y times 1 is equal to x times 3. So y is equal to 3x. 3x. That is proportional reasoning. Okay. You identify the 2 variables in question. Sometimes it might be an extended proportion, so you identify the 3 or the more than 3 variables in question, and then you solve it. Okay? But some people will do this mental math. X miles per hour, right? 3 hours will be 3x. 5 hours will be 5x. Okay? But sometimes they might ask it the other way around. For y miles, what will it be? You know, how many hours? So it is good to form the proportion. It is always good to form the proportion. So you say it. Okay, next one. Uh, a stone. This one is 1997. 1997 from 2ST. 1997 from 2ST. 1997 from 2ST. And this is number 6. A stone is a unit of weight equivalent to 14 pounds. Is a unit of weight equivalent to 14 pounds. If a person weighs 177 pounds, how many stone does the person weigh? How many stone does the person weigh? They say round your answer to the nearest tenth. Round your answer to the nearest tenth. Nearest tenth. Okay. In this case, to save time, use calculator. Round answer to the nearest tenth. Now, this is also proportion. In this proportion, what are the two variables? Okay, we have stone and pounds. Okay, we have stone and we have pounds. We are using proportional reasoning. Proportional reasoning. So, a stone is 14 pounds. So this means 1. A stone means 1 stone. 14 pounds, right? 14. And then 177 pounds will be how many stone? So 177, you put X. Put X. Okay? So in this case, you just form a proportion. 1 over X is 14 over 177. You do your cross product. Cross product. When you do that, you have that X times 14 is equal to 1 times 177. So X is 177. 1 times 177 is 177 divided by 14. Okay? You divide both sides by 14. And you just use your calculator to the nearest tenth. And that gives you 12.6. To the nearest tenth, 12.6. Okay? So 12.6 stones. Okay? That's it. Proportion. Okay, we check it off. The same year, 1997 from 2ST. 1997 from 2ST. Question 7. Car C travels 60 miles per hour. Car C travels 60 miles per hour. I just changed, in the actual question it was car A. I just changed this to car C, okay? Car C travels 60 miles per hour for 1.5 hours. 1.5 hours. Car D travels 40 miles per hour for 2 hours. Car D travels 40 miles per hour for 2 hours. 2 hours. Okay. Find the difference between the number of miles traveled by car C and the number of miles traveled by car D. Find the difference between the number of miles traveled by car traveled by car D, car C, I mean, and the number of miles traveled by car D. Number of miles traveled by car D. Okay? I think traveled is double L. If I'm wrong, please correct me. Okay? Traveled. Okay, now this is also proportion. It's still proportion. And I'm going to show you, if you don't like fractions, you know, we can do this and I will show you a trick. Because part of this video is to show you tricks that you can use to knock off, to be fast on the ACT. So let's start with car C. We have two variables. We have miles and then we have hour. Okay, this travels 60 miles per hour, so we put 60 and we put 1 here. Now, for 1.5 hours, 1.5 is 3/2. 1.5 is 3/2. So for 3/2, proportion, to save time, okay, if you don't want to do cross product, this is another way to save time. What will you multiply by 1 to give you 3/2? Is 3/2. Therefore, you can multiply the same thing here. 60 times 3/2. Okay? So this will be 60 times 3/2. To save time, you can check, especially if this is 1. You ask yourself, what will you multiply by 1 to give you this? But if not, I will do it, you know, but this is a shorter way. But I will still do it the normal way. So this will be 2 into 2 is 1, 2 into 60, 30, 90. This will now be 90. Okay? But if you want to do it the usual way, no problem. Miles, hour. But to be fast, it will be good if you do it this way, to be fast. You put 60, this is 1, 3/2, you put X. So if you do 60 over X is 1/3/2. So you say that X times 1 is 60 times 3/2. And that gives you 90 miles. 90 miles. Okay? To be fast, you just do it like that. To be fast, you do it like this. Now for car D, miles and hour. Car D is 40 miles per hour. So 40 and 1. For 2 hours, you multiply this by 2. So you multiply this by 2 and this will be 80. 80 miles. 80 miles. 40 times 2. So the difference will be 90 minus 80, which is 10 miles. That's the difference. 90 minus 80. This is difference. This shouldn't take you time to do at all. This shouldn't take you time to do. Difference between car C and car D means number of miles by car C minus number of miles by car D. Okay? Okay, let's do this. Another one. Question 8. We check this off. How many more here? This. Okay, this is similar figures. We will do that. This one is exam. Okay, this one also. Okay. Question 8. It says the specific gravity of a substance is the ratio. This is the same year, ACT 1997, Form 2ST. The specific gravity of a substance is the ratio of the weight of the substance, the ratio of the weight of the substance to the weight of an equal volume of water, to the weight of an equal volume of water. Okay? If 1 cubic foot of water weighs 62.5 pounds, if 1 cubic foot of water weighs 62.5 pounds, what is the specific gravity of a liquid that weighs 125 pounds per cubic foot? What is the specific gravity of a liquid that weighs 125 pounds? A lot of writing, right? A lot of writing. 125 pounds per cubic foot. Per cubic foot. So this is also proportion, ratio and proportion. Okay? So they both deal with cubic foot, so we are good. They both deal with cubic foot. Now, the specific gravity of the substance is ratio of the weight of the substance to the weight of an equal volume of water. Equal volume of water. So 1 cubic foot of water is 62.5 pounds. What is the specific gravity of a liquid that weighs 125 pounds per cubic foot? For 1 cubic foot also. So it's good. Like both of them are 1 cubic foot, 1 cubic foot. So we are good. We just use the formula, okay? So that specific gravity will be what? The specific gravity of the substance would be 125 divided by 62.5, okay? Because it's equal volume of water, 1 cubic foot, 1 cubic foot. If it was not, then we'll do it and we will do it to be equal volume of water. But now we are good because it's per cubic foot and this is 1 cubic foot. Okay? So if you divide this will give you 2. 2. Okay? Gives you 2. Pounds divided by pounds will, is ratio of 2 units. So it is unitless. Okay? Or because this is pound per cubic foot, pound per cubic foot. Okay, now the next one, let's check this off. The next one we'll do is the next one we will do is this one. This one is 3, extended ratio. This is extended ratio. Question 9. Extended ratio. It says, and this is a ACT 1996 Form 1 ST. ACT 1996 Form 1 ST. It says there are 16 ounces in a pound. There are 16 ounces in a pound. In a pound. If 1.5 pounds of burger costs $2.88, if 1.5 pounds of burger costs $2.88, excuse me, determine the cost per ounce. Determine the cost per ounce. Determine the cost per ounce. So here we are there are 3 variables here. 3 variables. Okay, what are they? We have ounce, we have pound, and we have cost. These are the 3 we have. Ounce, pound, cost. Okay, so with this we have to do it step by step. 16 ounces in a pound, so 1 here, 16. Okay, we put that. Let's draw a line here. Let's draw this as double line to demarcate it. Then 1.5 pounds of burger costs $2.88. So I'll put 1.5 pounds. I'll put 1.5 here, and I'll put 2. Let me put this cost in dollars. Cost in dollars. So 2.88. Right? Determine the cost per ounce. Cost per ounce. So in this case, I'm gonna draw this again. For 1 ounce, what will be the cost? Let's call it X. Let's call it X. So do you see this now? 1 ounce, let's now call it X. So for us to do this actually, we need to find this. And once we find this, then we can find this here. Okay, per ounce. So once we can get this here, I'll put question mark. Let me call it Y. Once we can get this here, then we can do Y 2.88, then 1 will now be X. Do you see that? So, but first of all, let's get this. And for us to get this, we can use this to get Y. Do you understand? Do you understand what I'm saying? We can use this tool here to get Y. How many ounces are in 1.5 pounds? Once we get that, we can now use this and this, then this and this. Okay? So we now use we form a proportion here, 16 over Y equal to 1 over 1.5. We do that first. So y times 1 is 16 times 1.5. Let me just put this like this. So y is 5 times 6 is 30. This is 9.0. So y is 9, right? Actually, it's not. So 16 times 15, 30, 3, 8, 1, 6, 6, 1. Okay, 5 times 6, 30, 0, 3. 5 times 1, 5 plus 3, 8. Okay, so this 2, 4, 8 plus 6, 2, 4, 24. 24, because this is point. We now put point. Right? Y is 24. So now, 24 ounces. So now we can compare. We can now do 24 over 1 equal to 2.88 over x. Okay, we can now form that proportion. Kind of extended ratio. So this means that 24x is 2.88. So x, 24 times x is 24x. 1 times 2.88 is 2.88. Okay? So x is 2.88. You can put times 1 here if you want to. 2.88 over 24, which is what? You can use your calculator to save time. 2.88 divided by 24. And that is 0.12. The cost. Okay? 12 cents. 12 cents. 12 cents. That's it. Okay? Proportion, but in this case, it's like extended three variables. Three variables. Extended proportion, actually. Extended proportion. But, I did it, to get this, and then I compared this and this. Yeah. I compared this here and this here. So, but for me to compare this and this, I gotta find this and this here. So, okay. Question 10. We have a lot. Question 10. So let's check this off. This is gone. This is similar triangle. This is similar figure, similar triangle. This will be similar figure and parallel lines. Okay. Let's look at more on proportions, then we go to postulates on similar figures and also similar triangles. And then we can call it a night and continue tomorrow. Okay. So here it says, this is a 1997 ACT 1997 from 2ST. From 2ST. Question 10 is a bit tricky. I will still call it proportion. I will still call it, it's algebra, but it's still, it's still under geometry. Okay, it's still under geometry. So question 10 and question 11. Question 10 and question 11, yeah. So, a little bit tricky, just a little bit tricky. So, it says here, for the area of a square to double, this is 1997 from 2ST. 1997 from 2ST. For the area of a square to double, the new side lengths the new side length must be the old side length, must be the old side length multiplied by what? Multiplied by, and they just put this, multiplied by what? Okay. First of all, what is the area of a square? Let's call this the, and you don't need to, you don't need this, but just to illustrate something for you. A square has 4 equal sides. Okay? 4 equal sides. So 4 equal sides, 4 congruent angles. 90 degrees. Okay? Each angle is 90 degrees. This is the length, and the area of a square is length squared. Okay, the length of one side, all squared. Okay, length times length squared. Let's call this the old and new. We have the original square and the new square. We are going to solve this way. Let us represent the area and the length of the original square with some variables, with some, well, we can use subscripts, okay? But we are going to represent them with different, with the same letter but with different subscripts. Okay, let's look at it this way. Let the length of the original square, or let's call it initial. Let's call it initial square. Initial. Okay, let the length of the initial square be Li. L subscript I. Li. Okay, initial length. And let the area of the initial square be A subscript I. Then let the length of the new square, let the length of the new square be Ln, and let the area of the new square be A subscript n. So we see that I is L squared I. Yeah, this is the area of a square. Length squared. And the AN is Ln all squared. So this is the area of the initial square is length of the initial square all squared. Area of the new square is length of the new square all squared. Now they said for the area of the square to double, so we're going to double the area of the initial square. What will you multiply the new length? The old length must be multiplied by what to get the new length? Okay, so if we double this now, double this, okay, double this, double the area. So if we double the area, we have A 2 times AI, and because this is an equation, whatever we do to the left hand side, we have to do to the right hand side. So this will be 2Li squared. Okay, so if we and we see, we now have to find, what we now have to do is, we have to find the new length. Okay, well, we have to find the new length, because if you double this area, this gives you this, then the new length, the new side length the new side length must be the old side length multiplied by 1. So let us solve for the new side length. We need to solve for this new side length, okay? Because this double area is this new area, okay? This double area is now this new area, But then they want us to now find the multiplication factor. What would this be multiplied by to give this? So this now means this new side length is 2 times Li squared. The new side length all squared is 2 times the old side length all squared. Okay, but they want us just the new side length, so we take the square root of both sides. Okay, we want to find the new length, so take the square root of both sides. The square root of both sides. They don't want us to find the new side length all squared. They just say new side length, and they also want the old side length, not that of squared. So if we do that, we have new side length squared is positive square root of 2 times initial side length all squared. So ln, the new side length will be radical 2 times, of course, radical the old side length all squared. And this implies that the new side length will be radical 2 times the old side length. So the answer is radical 2 is the answer. Radical 2. That is the answer. Okay? It's not difficult, it's just, and you know, you might call it proportion, you might call it equation, you might call it proportional reasoning. You know, you might call it proportional reasoning. Okay? So let's do question 11. Question 11. And we can check this off here. Here they said the formula for the surface area S, the formula for the surface area S of a rectangular solid, is, so they have S equal to 2 length width plus 2 length height plus 2 width height, where L is the length. And this question is ACT 1997 Form 2ST. ACT 1997 Form 2ST. Where L is the length, W is the width, and H is the height of the solid. Doubling each of the dimensions, doubling each of the dimensions. Now, what dimensions is it? Length, width, and height. Length, width, and height will increase the surface area. Will increase the surface area to how many times its original size? To how many times its original size? Okay. So let us. This is still similar to what we just did. Similar to what we just did. And you can call it proportional reasoning. You can call it proportional reasoning. So let's, we're gonna let's let the surface area of initial solid be SI. Surface area of new solid be SN. Length of initial solid be Li. Length of new solid be Ln. Width of initial solid be W subscript I. W initial, I is initial, N is new. I is initial, N new. And I am writing it as a subscript. Then width of new solid be Wn. Height of initial solid be H subscript I. And then height of new solid be H subscript N. So we are going to doubling these dimensions. Okay, so that means that Ln is 2Li. Okay, L subscript N is 2Li. W subscript N is 2W subscript I. We're doubling it. Doubling, multiply by 2. And H subscript N, new height is 2Hi. So the new surface area, of course, the surface area of the new solid would be 2 LNWN plus 2 LNH Hn plus 2 Wn Hn. That's the new. Okay. Now they said this is, of course, you can call this SI. You know, you can call this SI initial. Initial is 2 LIWI plus 2 LIHI plus 2 WIHI. Initial. Okay. What we are gonna do is, they said if we double this initial LIWIHI, it will increase the surface area by how many times in the original? So they want us to find a new surface area. But we are going to substitute this new length, the new width, and the new height. We're gonna substitute it here. Then we now look at the relationship. We now make the connection by how many times would you multiply this to give you that new one. Okay. So I'm gonna erase this here, so I will have space to write. So we now see that this new one now will be, if we substitute this is 2 times 2 Li times Wi plus 2 times 2 Li times Hi plus 2 times 2 Wi times Hi. That's the new one. This we substituted. So this will give us what? 4 LIWI plus now wait a minute though, wait a minute. We need to do this well. This is Ln is 2 Li, Wn is 2 Wi, Hn is 2 Hi. So this is actually 2 Ln, because this is 2 Ln Wn, let me write it here, plus 2 Ln Hn plus 2 Wn Hn. Okay, so this will give us, we substitute for this, because we doubled it. This is 2 times 2 Li times 2 Wi plus 2 times 2 times Li times H, 2 Hi plus 2 times 2 Wi times 2 times Hi. So this will give us 2 times 2, 4 times 2, 8 LIWI plus 8 LIHI plus 8 WIHI. So if you look at this is the new. This is the new surface area. What it will be in terms of the length, width, and height of the initial solid. This is the surface area of the new solid in terms of the length, width, and height of the initial solid. So they want us to, if we put this here, 2 Li, 2 L, this. If you compare, you will see that this is 4 2 LIWI plus 2 LIHI plus 2 WIHI. You see, this is like this. So, and this would be 4 times SI. So the answer is what? 4. 4 is the answer. 4 times the SI. Okay? And if you don't get it, ask me again in class if you don't get it. But, they are asking you, it's just finding if you double the original. Okay, you double the original length, initial length, double the initial width, double the initial height. Then how does it affect this initial surface area? What is the new surface area in terms of the initial surface area? That means you just multiply it by 4. The effect of doubling the initial length, the initial width, and the initial height of the initial solid, of the rectangular solid, would be the same as multiplying the initial surface area of that solid by 4. That is what it means. It's kind of proportional reasoning, kind of proportional reasoning. Okay, this video will be too long, too long, honestly, too long. We are done with this one. And actually, they gave you a diagram. I didn't draw the diagram, but they gave you a diagram here. They gave you the diagram. They gave you the diagram. Okay, they gave you the diagram here. Height, length, width. Yeah. So they gave it to you. And sometimes when you see this kind of questions on ACT, you don't want to attempt it at all, because maybe it's so many word problems and they give you the diagram. Well, you don't need the diagram at all. You don't. You do not. So ACT, sometimes they set it to discourage you. They ask several word problems to throw you off balance, or they draw the diagram also. We don't need the diagram to solve this. We do not. So you should not allow them to get you. Okay, you should not allow them to get you. Just notice, they don't set ACT for you to just easily pass it. No. If everybody passes it easily, would you call the exam valid? Would you call it valid? So, you don't want them to get you. Okay, you don't want them to get you. Let's solve one more question and we shall stop here for tonight. Let's solve one more question and then we continue part 2 tomorrow. Question 12. This deals with congruency. Congruency. This is ACT 1996 from 1ST. ACT 1996 from 1ST. If point C bisects line segment AB, then which of the congruencies must hold? Then which of the congruencies must hold? So they gave you the options, but you have a line segment. What is a line segment? Well, let us line. So continue with the vocabulary words. Continue with the vocabulary words. Vocabulary words. I think we stopped at 14. So put 15, line. Put 16, ray. 17, line segment. Line segment. So a line does not have an end. It has no endpoints. With a line, it is infinite. Okay. Of course, a line, the joins 2 points. But a line does not have an end ordinarily. If you talk about line AB, for instance, line AB, it is like this, line AB. Okay? Then array is, it has one endpoint with array. The other has no endpoint. It is infinite. So if you talk about array AB, it is like this. So this means that there is an endpoint at A and no endpoint in B. Then when you talk of line segment, it's actually, it has 2 endpoints, line segment, okay? It has 2 endpoints, so with line segment AB, it's like this. So when you have line segment AB, let's say we have AB, it has 2 endpoints, so it is not infinite. It is not infinite. Bisect, when we say bisect, you can say bisect. Bisect. 19, trisect. Bisect means divide something into 2 equal parts. Bicotyledon. Bilateral. Bilateral tops. Bilateral. Bisect. Divide something into 2 equal parts. 2 equal parts. So we have something into 2 equal parts. So let's call this point C. Point C bisects it. Bisects the line segment. So it divides it into 2 equal parts. So you have that this is equal to this. Okay? This is equal to this. So you have that line AC is congruent, is equal to line CB. Line AC is equal to line CB. Okay? If they write congruent, that's fine. That's fine also. Okay? Line AB, line AC is equal to line CB because it is divided into 2 equal parts. Yeah. But the actual thing is to write that it's equal. Okay? I know they said which of the congruencies must hold. Yeah. Line AC, line segment I mean, not line AC. Tired, right? Okay. Line segment AC is equal to line segment CB. It is not line. Line does not have an end. The line does not have an end. Yeah. Line segment AC will be equal to line segment CB because the point C bisects it, which means divides it into 2 equal parts. Okay. We are going to stop here for tonight. If you have any questions, please feel free to ask.
And you have a good